Hello, everyone. Welcome to another live episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and today we are going to be talking all about penetration testing and serialization vulnerabilities. So, to talk more about that with me, I'm joined by John Iwasz, who is a partner tech at Aviva and current Microsoft MVP. Hey, John. How's it going?
Oh.
I don't.
Hi,
Cool.
Leslie. Thanks for the intro. Today, we'll be covering binary serialization and sorry, I'm getting a little bit of an echo. Just give me a quick sec to tamp that down.
No worries. That happens to me sometimes too. It's weird. If it helps, I don't hear the echo on my end.
Yeah, not a problem. Okay, I think that mischief is managed. All right. So,
cool.
So I'd like to cover two topics in this in this session. One that every developer should be aware of is issues with binary serialization. This surfaces with the binary formatter, and it's been a long-standing vulnerability in .NET Framework and in .NET. This was removed temporarily in .NET Core 1.0 and then reintroduced in 1.1. But all of that comes to an end with .NET 9. So it's getting ripped out of the of .NET 9 altogether. There's going to be a NuGet package that you can bring into your solution if you really need it. But the goal is to get rid of the dependencies altogether. So let's drill into that just a little bit more.
All right. So I am curious, before you drill in like real deep, what exactly are some of the ramifications that can come about with the serialization vulnerabilities?
Sure. So this occurs when the message can define the type it wants to deserialize as. So consider your typical POCO or your data type object that has your standard properties, maybe ID property, some business specific properties, but many objects end up leaving an opening for the user to determine what to deserialize as. So, for example, how often do we have classes that have metadata properties, where you just have a dictionary of string value pairs to provide the caller with just adding in a property bag of anything they want? Those objects can be subverted to tell the deserializer to create a potentially vulnerable class and also include instructions in the constructor or malicious values and properties to perform operations that you as a developer don't want on your server. So, for example, .NET Framework includes a number of potentially vulnerable classes like claims principal that can be manipulated in the payload of the message to perform, say, a process.start and anything at the command line. So using that, you can launch an arbitrary executable on the target machine.
Awesome.
And this is not just limited to the binary serializer. Any message that can define the type to deserialize as is a potential vulnerability, including JSON messages. And we'll also get into that. It is possible to exploit this particular vulnerability using Newton soft JSON, and I have a working example of that as well.
Alrighty. Cool. So before we continue, I want to say apparently we're still experiencing echo issues. I don't hear it on our end. But for folks in chat, we're investigating it as we speak. So please bear with us. Yeah, so cool. So John, do you want to continue? Sorry, we're having some sound things.
Yeah, for what's worth, I'm not picking up an echo on my side.
Same.
Yeah.
Yeah, I'm not sure what this could be.
So everything I'm going to show is documented here, and probably won't get to everything that is here. So if after the recording you wish to drill in, all of the source and documentation that I'm going to cover is in this RCE serialization.net repo. And it starts with this true shot vulnerability and serialization vulnerabilities. But first, let's dive into serialization. Mm-hmm. So there's the binary formatter issue, but once again, this same pattern of defining a type in the message occurs both with Newtonsoft JSON and message pack, and likely others. So let's show, why is this a problem? Now there's some terminology here that most developers are not familiar with, a gadget chain. So that is a potentially vulnerable object that can be used to execute malicious code. So consider a generic object where you can tell the deserializer what type to deserialize as. And analyzing your entire assembly to find all potential gadget chains is, well, it's challenging. It may not surface on your DTOs directly, but perhaps one of the properties of your DTOs down the line uses a vulnerable class that a caller could take advantage of. So this example I'm going to show uses .NET Framework. And let's drill in. So I've got a sample test project that just exploits the binary formatter message directly without calling into an API. This is just in its most direct reproduction. So let's take a look at the serialization test for a moment, shall we? This guy launches calc.exe by using the binary formatter to deserialize this string. Well, it'll first decode the base 64 encoding and then take the byte stream and use the binary formatter to deserialize that byte array to a claims principal and exploit that claims principal to launch calc. Let that sink in for a moment. It's quite a bit to digest. It uses this whysoserial.net executable to craft this malicious payload. So one interesting point to note here is that it's impossible to create a malicious payload by serializing an object from .NET. You can't do it directly in .NET code. You need some other mechanism to go into the serialized message and manipulate it and create a malicious payload. That's where whysoserial comes in. So this is available on GitHub. It will programmatically manipulate that binary payload to inject code, specifically this calc.exe, into the constructor of claims principal. So what happens when you deserialize is the calc.exe or whatever command you inject will then execute. So let's take a look at that Git repo for a moment. But it's worth taking a moment to cite that this is considered malware. So if you clone this repo and you build it, your malware scanner will flag wisoserial.net exe as potentially malicious code. So you need to go into your, virus scanner, check your threats, remove it from quarantine. So I suggest doing this on a system that is not on your corporate network. You don't want your security operations center to come sending you a nasty message. And that applies to some of the other utilities that we'll be using as well. So
It's a good disclaimer.
use with caution. Don't avoid using at work unless you're working directly with a security team in the first place and they're well aware of what you're playing with.
Makes sense.
Yeah. So you don't want to get any nasty grams.
No,
All right.
not fun.
But if you haven't seen this this repo before, it's worth taking a closer look at it. This spun out of a wisoserial repo that did a dive into Java serialization vulnerabilities, and then a security researcher took inspiration from that to create this wisoserial.net library to exploit and test both binary and JSON payload messages. So I won't read this all to you. Please peruse at your own leisure. But this uses a variety of gadgets of potentially vulnerable objects to manipulate the dehydrated form of that object and inject a malicious payload. And you can see just the rather lengthy list: claims principal, claims identity, data set, even that in .NET framework were and still are vulnerable. If we've got legacy code lying around that's that uses binary formatter and also uses these classes well, you have a potential issue. It's worth investigating. There's our generic principle, and the list goes on and on. So this is the bad news. The good news is that in .NET, these holes have been patched. So the same vulnerability that may work in .NET framework with claims principle does not work in .NET. Right? That has been patched, even though the binary formatter is still present. However, there's a way around that too, and I'll show. So this uses a command line to generate that payload. So let's break it down a little bit and step into our first vulnerability. So we'll take the malicious string, we'll convert from base 64 and deserialize. Now, it may throw an exception during deserialization. As an attacker, do we care? Or do we care just that the executable launched? And it's the latter, right? Once the damage is done, the payload's been delivered, the executable has been launched, and we have potential command and control of the system. So this command line tells us what formatter to use. Could be binary formatter, it may be a JavaScript formatter, it may be the JSON.NET formatter. Which object do we wish to exploit? The claims principle. And it'll be base 64 encoded, and we're going to launch calc.exe. It gets worse from here. This is just the proof of concept. So let's see what this does when we fire it off at the command line. Now, bear in mind, I already unquarantined this. I already got the GitHub repo, built it, and jailbroke it. So you'll have to do those steps and It is documented in the wiki, but for the sake of time, believe me, we're not going to get through everything if I go through every single step there.
Okay.
So here's our malicious payload. It doesn't look like much, right? It's just base64 encoded string, but rest assured, in there lies a trap in the calc.exe. The command line, by the way, does accept a test parameter. So if you are brave enough to go ahead and run the exploit right then and there at the command line, and it'll deserialize. And what happens? There's command exe, there's calc.
Yeah.
All right.
Use at your own risk.
All right. So nothing up my sleeve. Let's just do this directly in test code.
So this is like a nice sort of sandbox to be able to kind of safely play with. What could go wrong if we don't secure this?
Exactly.
Correctly, right? Yeah.
Exactly. So this kind of takes it in. It's our lab environment, our sandbox. It's our safe space to play with these without fear of exploitation.
Nice.
All right. So let's set our breakpoint. And debug. Sorry, that is not the test I wanted to run just yet. I'm giving you, this is a little preview of what's to come. You'll see I'm not using calc.exe. There's netcat. And that opens, we'll get to that. That'll open up a reverse shell and ruin somebody's day. But let's just run calc.
Oh,
there we are.
It's not debugging. Looks at it, but
yeah, let's do this one. Start small. And pardon for the screen crunch there, but normally I'm at a much smaller font size. All right. Set breakpoint and deserialize and just let it run. Apologies, my F10 doesn't want to keep going, so let's just set breakpoint and.
Yeah, that's weird.
Yeah. All right, there's our deserialization, and there's calc.
Cool. So it's behind the scenes happening.
We got our proof, but let's take a look at this to-do API, and now let's look at how this might actually work to compromise an API. So how is this exposed? We've got this, by the way, is based on the simple, hello world to-do web API project that's on Microsoft Learn. This one's just a little more malicious and has an intentional vulnerability. So we've got your to-do POCO DTO object, our metadata item. And we've got a object coming in, data type, and I'm intentionally using this binary JSON converter that will use the binary serializer, use the binary formatter to deserialize that bit of code.
And is that a class that you created, or is that part of a different package? Or
this binary converter is one I had created, but under the hood, it uses that binary formatter vulnerable class.
Gotcha.
All right. And let's take a look at our REST requests. So once again, simple to-do API that will create a task, walk dog is complete. This one's sends a benign data table that doesn't mess with the system just yet, but this proves out that we can send a base64 encoded payload, and then we got our malicious payload here. So let's go ahead and run. All right, we're up. I'll just put this off to the side while we step through the API requests.
Mm-hmm.
And just to prove it's working, we've got an empty array, right? It's a to-do list. We haven't populated anything in the to-do list yet.
Right.
So there's our walk dog task. And there's what it looks like when it comes back down. And we'll just set it to is complete, pull down the list to show everything's working as we expect. Nothing doesn't look so malicious just yet.
Mm-hmm.
Send in the data table, right? No calc launches. It's a benign string, but enter our calc exe, and we'll pass that data into that metadata that that calls the binary formatter. And there's command exe that just launched, and there's our calc. So if this were deployed in a production environment, I now have a way of launching arbitrary executables on the host, and
Right.
that will execute under the rights of the hosted account. Right. Mm-hmm. So that all speaks to using a least privilege approach. So we want to follow defense in depth. So even if your service gets compromised, limit the blast radius by reducing the service account's rights to only that which it needs. So it shouldn't be like running as local admin. Who would do that, right?
Right.
So I happen to be running this locally. I am local admin, but of course in a production environment that shouldn't be the case.
Mm-hmm.
All right. Now,
so that seems like a very common pitfall or easy pitfall to fall into. Like, it didn't require that much really to seemingly be able to pull up something malicious potentially. So it's a little scary.
And the capability to do that is out there. Whysoserial.net is out in the public. There were some rather good talks on this particular vulnerability at Black Hat conference last year. Mm-hmm. Black Hat, by the way, if you're not familiar with that, is a cybersecurity conference. When you picture the stereotypical hacker with a hoodie at the keyboard in a darkened room, that's who goes to these. As well as Black Hat has more corporate, more of a corporate attendance. DEF CON that runs right after Black Hat has the more stereotypical hacker that you would expect. If you do go, have your devices in a Faraday bag.
Is there also a requirement to get a black hoodie and dimly lit?
It's it's part of the uniform. Yeah.
Oh yeah.
So I kind of teased this one. So if we were in a in-person room, I would ask, raise your hand if you've heard of NCAT before. NCAT is one of those tools that might get the attention of your security operations center. So once again, use with caution. NCAT is part of a suite of tools for doing network penetration testing. It'll do port scanning. It can be used to open up a connection across two machines. It's very lightweight.
Does NCAT stand for anything? Is that, or is it just the name?
Network, probably network capture or something. I'm not sure precisely, but this. Let's take a look at the sites. Pardon me for a moment while I bring it up.
Oh, no worries.
Yeah, it installs Nmap, and that is a pretty powerful tool for inspecting network. It can there we are. Yeah, it's pretty versatile. It can scan for services that are running on network. So not only do a port scan, but also determine what version of a service is behind that port. So if you've got, I don't know, let's say a SMTP server that's not kept up to date, or an FTP server that's insecure, running an insecure version, well, that could be another potential vector for an attacker to exploit. It, by the way, was also featured in the movies. If you go back to Matrix Reloaded, Trinity is running a scan here using Nmap to find some open ports, and then does a vulnerable exploit on an SSH client.
Dang, so this is like peak hacker stuff, is what you're trying to tell me.
Yeah, if you're running Nmap, NCAT, or any of those related tools on your corporate network, just be forewarned. You might get a call from your security operations center.
Good to know.
But I'm here on my personal environment. I'm in a sandbox, so I've got a little lab set up here. So before I step through this, because there's a lot that's going to happen when I launch NCAT and I open up a reverse shell. So let's get a little bit of background on what's going on here first before stepping through. So that brings me back to the documentation here. And we'll go back to our index page. And here's why I wanted to use the repo documentation rather than I have GitHub pages published. GitHub pages, by the way, don't natively support mermaid diagrams. So here's a simple anatomy of what a reverse shell looks like using NCAT. So on your attacking machine, you open a port that you're listening on. In our case, it'll be port 2222. And that attacking machine is just waiting for a connection to be made from the target host machine. And our Windows machine is our target. So we'll just run silently. And then from the host machine, we'll put in the this NCAT command that will open a reverse shell to the IP address on the Ubuntu machine, on the attacking machine. And at that point, I'll have a command line access from the target. So how does that work for this environment? So I can use, for our demo, I can use just our Windows subsystem for Linux, start listening on port 2222, and send a malicious payload using that binary formatter vulnerability that will open up that ncat command. And then it's like I'm sitting at the command line under the identity of that service request I just made.
Right.
All right. Who wants to see that in action?
I do want to see that in action.
All right. So there's our Ubuntu machine. I'll get the IP address up. Okay. So I want to pull down ifconfig because I want to get my machine's IP address, because when I open that ncat command, I want to go to this IP address that corresponds to the host I'm running here. One more time with the password. Okay. And I have config. Okay, so I want the Ethernet port here, this guy. So now I want to use YSO serial to craft that payload. Let's use command prompt.
Doesn't matter which one you use in this case.
This guy is where we're going to be waiting for the request to come in, and this will generate our malicious payload.
I see.
So let's pull down our command line operation because I have it in here conveniently. In the test project. Yeah, there's our ncat command. So what we want to do is take that and just plug in our IP address. So we'll run this with YSO serial and we'll get our malicious payload. And all right, there it is. Let's bring it into our REST host environments.
So. And just to be clear, you're using an Ubuntu machine as the example here, but like this malicious intent could happen with any predatory machine, right? It doesn't have to be.
That's right. That's right. Anything that can run what you want is a lightweight client like ncat that can open up a port, and you don't necessarily need to use ncat. It's just awfully convenient. So I'll open up ncat and I'll just listen on port 2222. All right. And this is still running. So I'll launch. Let's bring this up. Because ideally, I'd like you to see this.
Having it at the same time.
Yeah. Yeah, which the screen real estate may not make that easy. There we go. All right, back to the requests. Now it's a little hard to see, but what I did here was paste in that malicious payload over here that I generated, and let's send the request. There. See that launched, and look what happened right here. Consider this. I'm running my test project under IIS Express, and look what directory it just opened for me.
Oh
Right.
my gosh.
So now I'm at the command line of the host machine from I know it looks like Windows, but I've successfully opened up a reverse shell back to the host machine that I just targeted, and I maliciously used ncat to open up that reverse shell on the target Windows machine. I've got command and control now. Now I, as a hacker, can download other tools I want onto the machine. I can land and expand and maybe do a lateral move into somebody else's network. There was a pretty famous case of an IoT device at a casino getting exploited. It was an aquarium thermometer. And hackers broke into that IoT device and did a lateral move into the casino's network and downloaded and exfiltrated a database of all of that casino's high rollers.
Oh my gosh.
Yeah.
It's pretty scary.
So at this point, I can begin to, use curl and maybe, let's see, is curl installed on here?
Yeah.
Right. I got curl here. Right. I got curl. I can now begin to download whatever I need.
Mm-hmm. Lovely.
All right.
Yeah. So, yeah, that's quite terrifying. Now, obviously, my next question would just be, how do we prevent this from happening?
Yeah. Yep. So
best practices.
Right. So the obvious one is don't use binary formatter, of course.
Cool.
There is the binary reader, binary writer. That's okay. That one does not have this issue. You can try and use a serialization formatter. I don't recall the exact name of this, but it's a helper class that executes prior to deserialization, and you could try to inspect for types that you don't want to use, that you don't want to deserialize, but that approach has been fraught with problems because hackers can put in escape characters and screw up your string parsing. It's really not a terrific approach. A simple upgrade, well, not so simple maybe, but upgrading from .NET Framework to .NET will get rid of quite a few, but not all. You could remove references to assemblies that you don't need. Like, for example, if you're using claims principal, if you're referencing claims principal through one of, maybe that's an assembly that you can remove. I know that's a long shot for some of the legacy .NET applications. Microsoft has released a statement that the binary formatter is not only insecure, but cannot be made secure.
So just don't use it.
Yeah. But wait, there's more. There's also an issue with the with Newtonsoft. So let's open that solution. Let's stop this. And I don't think we're going to have time to get to the third one, but that third one also includes an example of exploiting the Newtonsoft serializer in .NET 8. It's more difficult to do, but it's possible. All right. So remember when I said that you are subjected to this vulnerability if the message includes the type to deserialize? Well, look at what we have there, that $ type. So this arises when you change the Newtonsoft's default configuration. So if we go to, let's say, global ASAX in here, start web API config. This is where it all, where it all falls apart. This type name handling property. If you change this, by default, this type name handling property is set to none. And that's great. That's what you want. This issue does not occur if that's what you have. But if you set it to anything other than none, then what ends up happening is you get that $ type metadata attribute that gets deserialized implicitly by serialized and deserialized by Newton solved without you having to do anything additional. It becomes part of your payload, and that once again can also be used to exploit the system. So let's take a look at our requests and responses. Here I'm using the object data provider to run calc, and this uses method start and ultimately uses system diagnostic process to get instantiated from this object data provider. Right? And we're passing in calc.exe into the start method of the process object. And what do you think that's going to do?
Well, I imagine not not some very safe, friendly things.
Yeah.
Oh Lord.
Yeah.
It's so freaky just seeing this behind the hood.
Yeah, this is really why you want to get rid of these classes. And
Yeah.
I imagine there are some people on the call that are probably doing a search through their repos for binary
Right,
formatter
yeah.
and type name handling right now.
I mean, you said Newton soft. I'm like, everyone uses Newton soft. What?
So the good news with it is that unless you go out your way to set that property, you're okay. You're not going to get this $ type. And moreover, if you're using system text JSON with .NET, you're not going to have this metadata behavior.
Okay.
But if you do, here's what ends up happening. And I'll skip right to the punchline here. And there it is. It's not just with the binary formatter. And once again, this could happen with message pack if you're not careful. So, take a look at your serializers and specifically your deserialization settings, and make sure you're not opening the floodgates to let the message define what type to deserialize. And it doesn't matter whether you're serializing it to binary or to JSON. You want to get rid of this. You want to. You don't want to let the message tell you what type arbitrarily.
Makes sense. So, darn, I had a follow-up question to this and I'm blanking on what it was. But yeah, I mean, is there like a way to kind of do some automated testing when it comes to detecting these sort of vulnerabilities?
Yeah. So there is the code analysis rule. You can use code analysis rules. Microsoft has released some updates that, in fact, I have some enabled in another project that looks specifically for type name resolver. And it also looks for uses of these other vulnerable classes like object data provider. So these code analysis rules are disabled by default, but if you download the rule set and enable them, and I have a solution where they are enabled, you can shift left, right? You can do some static code analysis before you check in and look for these vulnerabilities. So let's take a quick look at this secured project, and you'll see what I'm talking about. Ideally, we don't want this landing in repos in the first place. Right. Oh, by the way, I see somebody mentioning Kali Linux. Yeah. Kali Linux is your hacker's Swiss Army knife. That is definitely something you don't want to install on your corporate network without permission. You're bound to get the attention of Security Operations Center. But that has just a suite of tools for doing open source intelligence gathering. If you happen to exfiltrate some encrypted passwords, it's got password cracking tools that make use of rainbow tables and a lot of patience.
Wow.
Yeah, it's that one. That one's got definitely has some malicious tools in there. So this editor config is what I want to draw your attention to. This guy.
I love editor config. I think it's underused in BS.
Yeah. So let's find.
Yep. Also, yeah, for those who don't know what editor config is, it's a cool file that lets you configure specific aspects about your project, everything down to refactorings, or analyzers, white space, anything that you want to have consistent across an entire solution that you have, making it really easy to keep things consistent, either for just yourself or for your team. Anyway.
So here's an example of the code analysis rules I was referring to. So JavaScript serializer uses these four, for example, are introduce vulnerabilities similar to what I was showing you earlier. Let's look for type name handling. I think that's the one. Type name handling. Yeah. Do not use type name handling values other than none. This is your Newtonsoft vulnerability. If you haven't set to anything other than none, that's where the vulnerability comes in. So this is how you start to shift left in your security analysis.
Sweet. So what that will look like is the next time you try to set type name handling to anything other than none, DS is going to yell at you and not let you build if you set the severity level as an error, right?
Right.
Cool.
Right. Now, of course, you can have a developer that goes in there and disables the
sure.
analysis rule, but that's what code reviews are for, right?
Mm-hmm.
That's why we have our pull request reviews.
Yeah.
All right. I know we only have about 10 minutes left, but I do want to touch on the juice shop exercises. This is where Nmap comes in handy. So let's go back to our Git repo here. And go back to our docs. And let's take a look at juice shop. So this is maintained by OWASP, which everybody here should be familiar with the OWASP top 10 vulnerabilities. If you're not, go here, familiarize yourself. Well, maybe not there specifically, but OWASP.org. And I'll correct that link. These guys highlight common web vulnerabilities. You want to review the OWASP top 10. They also maintain a set of intentionally vulnerable applications. So a note on ethical hacking. You don't want to port scan a target that you're not authorized to scan. Don't attack somebody for the sake of attacking somebody just to get familiar with the tool. There are these intentionally vulnerable applications online that have allowed open season on hacking them, like OS Juice Shop, which is intentionally vulnerable. Cool. They invite hackers and can be used as a hacking target to test your skills. I do have instructions here for installing Juice Shop locally. I personally prefer that because, well, the online hacking target could be taken down by somebody else. You're not the only one that's going to be hitting it. So I've got instructions for installing a Docker instance. But we've got these reconnaissance tools. I mentioned Nmap. These are referred to as like open source intelligence tools. consider for a moment if you're a hacker and looking for what databases might a company use. Well, you can look at simple open source intelligence like job postings. Are they looking for SQL Server developers, Oracle developers, MySQL? That would give you a hint. Now that's active. I'm sorry, that's passive open source intelligence. If you're doing an active scan, well, now you're starting to get into these tools. And by the way, there is a vast network of open source intelligence tools. Some are better maintained than others, but this is your go-to for looking for what's relatively current. Some of these do fall out of support. And that, by the way, is also what you'll find on Kali Linux. Many of those tools that you just saw on that web are installed on Kali. So Nmap, though, deserves some attention. So again, use with caution. Don't get on your Security Operations Center radar. But you can do port discovery with this. You can install it on Windows, winget insecure.nmap. And let's do a port scan of Juice Shop. This is one we're allowed to do. So let's see what ports are open here. We can be more surgical about this. I just passed demo OS Juice Shop without any parameters. It tries to run silently, so when it does a ping over TCP, it sends a sync message without an acknowledgement, so it never completes the connection, and that might bypass some, a lazy firewall that's not looking for that. But we can also detect what versions of services are running on those ports. And we can also see what operating system the server may be running under. Give it a moment to finish its port sweep.
Mm-hmm.
Now, I did ask for more information. It's checking on the versions, not just whether the ports are there. So sure, it'll take a little bit more time. That they're behind a big IP F5 load balancer, they're running Apache.
Mm-hmm.
All right, and they tell us which version of Apache they're running. So, maybe there's some vulnerability in that unpatched Apache server that you can exploit. And lastly, we can see what operating system they're running, at least a reasonable probability of what operating system they're running. And just for out of curiosity, I also sometimes do a port scan on my own home PC just to see if I left something open that I didn't intend to. So, you can certainly Nmap yourself. Nobody's going to come back, bang down your door on that one. And let's see, it found OpenBSD. And one of these versions. It's reasonably sure at 88%. And so maybe you can start looking for vulnerabilities in OpenBSD. That's certainly an option. Let's take a look at a mass. So a mass will do a scan for subdomains off of a root domain. So we've got OS Juice Shop here. If I launch a scan here, right, it'll take a moment. Sorry, that's a Linux item. It'll take a moment to finish that, but like a like a good cooking show, we've got
Uh-oh. Did I lose you? Oh no. Oh. The cliffhanger.
Produce.
Oh, you're back. Cool. I think you cut out a little bit there.
So off of
yeah, we do need to hear the cooking show simile. So open-ended. 1 second, y'all. Oh, let's see. Hey, you're back.
Yeah, it looks like my network just briefly dropped out there.
Oh, no worries. Welcome to the live show.
Yeah, we're at the tail end there, but let's. Yeah. All right.
So I think we lost you around the time you were about to try out a mass.
Got it. So I should be sharing screen again.
Mm-hmm. Oh, let's do the new shared screen.
Yep, there we go. Perfect. Cool. All right. Sorry for that to interrupt. So where a mass is useful for is looking for other subdomains that are off of your root domain. And this will scour DNS and look for a domain that you may have forgotten about. Facebook had an issue about, I don't know, maybe a decade or so ago, where a developer had put out, test.facebook.com, what have you. And there was a vulnerability found in a Facebook authentication process that lets somebody swipe a session ID, an auth token. And that was patched on www.facebook.com. It was unpatched on a pre-production site that went against production data. So you can guess what happened there. Somebody found that subdomain without the patch that was going against customers, users, public data, registered user accounts, and was able to get a auth token that worked at www.facebook.com. So, you may have a rogue, subdomain, maybe somebody's deployed and forgotten about. Well, this will find it.
Gotcha.
Security header. I'll close out with this one since we don't have too much more time left. But if you've got a public facing site, this will look at your securityheaders.io rather. I'll update that link. Oh, scan. There we are. So it'll tell you if your site is missing some recommended headers. Like contents, like this one's missing content security policy. Right. That everybody should have that. What we did not get to, I know, sure, Leslie, we're approaching your time there, but what we did not get, what we did not get to was using ZAP, Z attack proxy, which once again, it is documented in the wiki on how to install and how to run this. This is useful for doing some automated penetration testing. So you can browse to a site, and the traffic will be captured by ZAP, and you could, after you browse to, say, your target site, you could run an active scan against that target site by adding it to your context. And I like to use these settings. Apply a low threshold for considering something a vulnerability, and go to insane strength for doing the attack. And if you do this against that demo juice shop site, you will find a SQL injection vulnerability on one of the routes. So as a homework assignment, drill into this a little bit. And there's a section in my wiki where I have a walkthrough of that SQL injection attack. So if I go back to GitHub for a moment, on Juice Shop, if you scroll down the page there, there's instructions for a few pretty well-established vulnerabilities with Juice Shop. So here's your homework. Use Zap to find a SQL injection vulnerability and exploit that, and no peeking at the solution. And there's a pretty simple password cracker that, password cracking that you can step through. Once you step through the SQL injection vulnerability, you'll be able to exfiltrate usernames and loosely encrypted passwords. And lastly, you can create your own admin account by this mass assignment vulnerability. So sometimes developers will leave an extra property in a data type object that should not be present. Like imagine if you're creating a user and you can specify what role the user is in when you're submitting the request. An admin should be able to do that, but a user that's self-creating their account should not. But yet that role property still exists. It may not be populated by the UI, but it's present on the DTO and the API recognizes that. Well, you've got another vulnerability, and that's what this mass assignment vulnerability is about. You can create an admin account without being an admin.
Gotcha. Well, sweet. That's a lot of tools. Obviously, we'll share the link to this repo in the show notes once it goes on demand. And yeah, anything else before we wrap things up, John? That was pretty packed. I'm quite scared. Hopefully everyone else is scared too, so we can all work to create more secure applications.
Well, mission accomplished then.
Sweet. Cool. Well, John, thank you so much for sharing all of that really useful information and how to infiltrate some not so secure locations of your applications and stuff too. So if people want to reach out to you and ask any more questions that they might have afterward, where can they go?
So let's see. You can drop me a personal email at my last name, iwaszj@gmail.com. You can find me on Twitter under JIWASZ, and if you search for me on LinkedIn, I'm the only Johnny who was on
there. Awesome. I wish I could say the same. I'm not. Cool. Well, John, thank you so much for being here. Really informative, very important stuff, especially in this day and age. So, yeah. And thanks to all the viewers for sticking it out through some of our technical difficulties. And I hope all of y'all learned something new. Stay tuned in the next day or so for some links to everything that we were exploring in the GitHub repos. And yeah, so until next time, happy coding, y'all. Thanks, everyone.
Thanks all.